Half-life of silicon. Okay, again, we're using this. A0, e to the kt. But for half-life, it's just this. Half equals e to the kt. Okay? Now, it takes 710 years, so a half equals e to the k, 710. That's where it goes. Okay? I'm now going to natural log both sides. Remember this? Natural log both sides, because this will just give you 710k on the right-hand side. Okay, so let's take a look at this. Right, we have 0.5, the natural log, divided by 710 equals, right, negative 0.000976, okay? It's going to be a very small number because it takes a long time to decay by half. So, we have this as the growth rate k, okay? That's what k equals up here. Now, how much in 300 years, if 30 grams is present now, how much is present in 300 years? So, again, that's where 30 is. If 30 is present now, that's now. Our growth rate is all of this, or decay rate, sorry. There's t. Oh, I do know where it is. Oh, in 300 years, right. I'm actually going to write 300 there. So this is, I don't have to log both sides here. I'm literally just putting 300 there, okay? Okay, oh dear, right. So, this is, again, for me, right, negative 0.000976 times 300 equals, that's e to the power of that, times 30. I get 22. 20%, now how much is present in 300 years? Well, okay, I guess I get 22 grams. That's what I get. Hopefully I'm right. Double check your work, okay? But that is just put that in your calculator. Once you've got that k is that. Okay, next one. Again, another, this one's growth. So again, we're going to be using A0, e to the kt. Or RT, just the growth rate, the R, or K, whatever. Okay, so again, let's have a look at this. We started with 320. We ended up with 340. And it took, look at this, 2002, 2012, it took 10 years. Okay? Right, so I've got all the information in. Again, trying to find this growth rate. Divide both sides by the number next to the letter. So, 340 divided by 320 equals, that's 1.0625 equals e to the 10k. Okay, remember, log both sides. This is just 10k. So the natural log of 1.0625 equals 10k. So I'm going to hit the natural log of that, then divide it by 10 and get this, 0.006. That's what k is. That's my growth rate. Okay? Right. So this is what this is asking for. What is the function? The function is this. A equals 320, because that's the starting amount. E to the 0.006t. That's the exponential growth function. In 2019, you are just going to put, think about it, it started in 2002, that's just t equals 17 into the equation, and you keep on going, okay? That's just plug it in your calculator. How long it takes to double? Right, okay, you're going to use this instead. Remember, 2 equals e to the kt. Doubles, okay? But we also know what k is, so I'm going to write k in here, 0.006t. So again, it's just like doing this above. Let's just log both sides, ln, ln. Okay, so remember the L natural log of 2 just equals 0.006t. So I'm going to divide both sides by 0.006. So here we go, 2 natural log divided by 0.006 equals, that is 115, about 116 years, 116 years or thereabouts, okay?